Dear children, greetings of the day. In the previous lecture, we have studied only the components making AC circuits. The main components are R, L and C. ठीक है, हम लोगों ने तीन components के नाम देखे थे. First was resistance. Resistance का behavior AC as well as DC circuits में same होगा. Second was the inductor L, जिसका बिहेवियर एसी सर्किट्स में स्टडी किया था आपने कि इट विल ऑफर द इंडक्टिव रिएक्टेंस एक्स एल विच इज इक्वल टू ई डिवाइडेड बाय आई. सपोज आप यहाँ आर एम एस लेते हैं तो नीचे भी आर एम एस लेंगे. सपोज आप यहाँ पीक वैल्यू लेते हैं तो नीचे भी पीक वैल्यू लेंगे. बट फॉर डीसी, ठीक है, अगर हम इंडक्टर का बिहेवियर देखते हैं डीसी के लिए, so for DC circuits, that is for direct current circuit, frequency is equal to 0. And in the previous lecture, we have also studied the formula for XL, which is omega L, so 2 pi FL. So if frequency is 0, XL is equal to 0. It means the pure inductor offers zero resistance to a DC, hence it cannot reduce DC. ये DC से means इसको पास कर देगा, but ये AC के बहुत हाई फ्रीक्वेंसी कंपोनेंट्स को ब्लॉक कर देगा because XL is directly proportional to the frequency. So जैसे जैसे frequency increase होगी, the value of XL will increase. So for high frequency components, inductive reactance will be greater. Now, the third component was the capacitor, which is represented by the capital letter C. So, now we are going to study when AC voltage is applied to a capacitor of capacity C, then which type of phenomena or effect we are going to study. So let's see the circuit. This is a circuit diagram in which we have taken a capacitor of capacity C. This is connected to an AC source which has the instantaneous value of EMF. Let we are taking it as E. So the instantaneous value of EMF is E equal to E0 sine omega t, as we know that it is a sinusoidal function. But remember, over here we can also take cos according to the given conditions. Now, the current flowing in the circuit, because the name of the current is alternating current, तो जैसे ही alternating current इस circuit में flow होना शुरू होगी, this will be supplying charge Q to the plates of the capacitor, which will produce a potential difference across the plates. But the meaning of alternating current means after every half cycle current will change its direction. ठीक है, आपने alternating current का ग्राफ देखा हुआ है. The graph is this type of sinusoidal. If this is first half cycle, over here the current is positive, the remaining is second half cycle where the current is negative. So after each half cycle, means suppose at this point, when the current changes its direction or reverses its direction, the capacitor is alternately charged and discharged. So remember this, it is charged and discharged. So we can take the magnitude of charge on the capacitor. So assume करते हैं हम कि let Q is the charge on the capacitor, which is the instantaneous charge, because as the current is changing its magnitude from 0 to maximum, then maximum to 0, then again 0 to maximum in opposite direction, and then again maximum to 0. Similarly, charge will change its magnitude. So suppose Q is the instantaneous charge at any given instant t. Then we can write the potential difference across the plates of the capacitor will be Q by C by the expression Q equal to CV. Now we will be using another relationship also, that Q is also equals to IT, but as the Q is a time varying function, hence I is the time varying function. Therefore, we can write I equals to d by dt of Q. So, over here we can express I equals to the rate of change of instantaneous charge flowing through the circuit. Now, for AC circuits, we can represent the instantaneous EMF as E. Therefore, we may have Q equal to CE. तो इस Q को जब आप यहाँ पुट करेंगे, बिकॉज E तो साइनोसॉइडली चेंज हो रहा है, सो Q भी change होगा. So therefore it is d by dt of C, and putting the value of E as E0 sine omega t. Up whenever you want to differentiate, you have to take the constants outside the differentiation. So we may get constants as C, that is the capacity, and the peak value of EMF. तो इन दोनों को आप बाहर ले लेंगे. C into E0 into d by dt of sine omega t. Now check the derivative of sine omega t. So again we will be going to the basics. D by dt of sine t is equal to cos t. But d by dt of sine omega t is equal to omega into cos omega t. So putting the value I equal to CE0 common into omega into cos omega t. Again we will be going dimensionally, as this is current. This cos omega t is dimensionless. So this value should be dimensionally equal to current. Therefore, we can write it as I equals to the peak value of current. इस तरह से लिख सकते हैं हम इसको, into cos omega t. So we may represent the peak value of current or the maximum value of current as C into E0 into omega. अब आप अगर ओम्स लॉ के अकॉर्डिंग जाते हैं तो दिस इज E0 divided by I0, which should carry the dimensions of resistance. So this is equal to 1 upon omega C. तो 1 upon omega C को आप बोल सकते हैं कि ये एक ऐसी क्वांटिटी है which is analogous to the resistance. So in this context, when AC source is connected to a capacitor only, this value we can represent as the capacitive reactance. Means एक ऐसी क्वांटिटी जो एसी करंट को अपोज करती है, एंड विच इज इक्वल टू E0 अपॉन I0 इक्वल टू 1 अपॉन ओमेगा C, और दिस में ऑल्सो बी ERMS अपॉन IRMS. ठीक है, अब चलते हैं हम इस इक्वेशन पर वापस. We can write it as I equal to, because इसका जो हमें फेज डिफरेंस कंपेयर करना है विद द इंस्टेंटेनियस वैल्यू ऑफ EMF के फेज डिफरेंस से करना है. सो वी कैन राइट इट एज साइन omega t plus pi by 2, because sine remains positive in the first quadrant as well as in the second quadrant. So now if we compare this equation with the equation of instantaneous EMF, we may check that the current leads by pi by 2 as compared to instantaneous EMF. So current will be maximum, it will be maximum when complete sine will be 1, it means we can take that omega t plus pi by 2 equals to कंप्लीट वैल्यू जो आप लेंगे साइन की वैल्यू अगर 1 हो जाती है तो करंट की वैल्यू आपको मैक्सिमम मिलेगी. Hence we can say the maximum value of current, that is I0 equal to E0 divided by XC, where XC is the capacitive reactance. Now from these two equations, if we are going to draw the graph of E and I, that is EMF and current versus omega t, we are going to get the following type of graph. So you can see the figure attached shows the first diagram. ये जो आपको first diagram दिया हुआ है अभी तक आप recognize कर पा रहे होंगे. This is called as the phasor diagram, and the second diagram shows the graph of V and I versus omega t. For V we can also use E. तो पहले हम इनके equations लिख लेते हैं. Equation for E is equal to E0 sine omega t when we are using a pure capacitor for AC source. And the equation for instantaneous current is I equal to I0 sine omega t plus pi by 2. अब इन दोनों इक्वेशंस को जब आप कंपेयर करेंगे, so what do you check? That the alternating current means I leads the alternating EMF by the phase angle of pi by 2, क्योंकि इसमें प्लस pi by 2 है. जब भी माइनस pi by 2 होगा then you will say that it lags, but over here we are getting plus pi by 2. It means जब आप दोनों equations को simultaneously लेंगे, suppose you are taking t equal to 0. So when we put t equals to 0, we get the value of E is equal to E0 into 0, because sine 0 is 0. So we get E equal to 0. But simultaneously at t equals to 0, this value is going to be 0, but this is sine pi by 2. So we are going to get at that instant the maximum value of current. So over here in the graph, this is the maximum value of current when t equal to 0, but the value of instantaneous EMF is 0. Hence we can say that the current leads the EMF by a phase angle of pi by 2. अब चलते हैं हम लोग फेजर डायग्राम में. मीन्स इन दिस डायग्राम, सो इन दिस डायग्राम यू मे चेक द peak value of EMF, means this is the peak value of EMF which makes angle omega t with the horizontal axis, and इसको आप हमेशा एंटी क्लॉकवाइज डायरेक्शन में लेते हैं. अब यहाँ पर हम लोगों ने बोला हुआ है कि करंट लीड्स द ईएमएफ बाय पाई बाय 2. सो जब आप इस पॉइंट से 90 डिग्री मीन्स पाई बाय 2 एंटी क्लॉकवाइज डायरेक्शन में जाएंगे, so you will be getting the peak value of the current. So obviously current magnitude will be less than the EMF magnitude, because we can get I equals to E divided by XC. तो XC की बहुत significant value होगी. Therefore the magnitude of current will be less than that of E. So we are getting a higher peak of EMF, whereas the lesser peak for the current. Therefore, on the vertical axis means ये आपको ये जो V का peak है उसका vertical axis पर जो projection मिलेगा, that will be giving you Vm sin omega t1, and the vertical projection of current on this axis will be giving us Im sin omega t plus pi by 2, because it leads. So in this way, if we are going to form the expression for capacitive reactance, we can check Xc equal to E divided by I, or these are the instantaneous value, or this is maximum value upon maximum value of current, or RMS value of EMF divided by RMS value of current. So we may have another formula as derived earlier. This is 1 upon omega c, or 1 upon 2 pi fc. So where f is the frequency of the AC source. So we may check dimensionally that it is analogous to the resistance. Hence the function of capacitive reactance in a purely capacitive circuit is to limit or control the amplitude of current. So I zero के amplitude means maximum current को control करेगा ये. इसका रोल सेम वैसा ही होगा जैसे कि रेजिस्टेंस का एक प्योरली रेजिस्टिव सर्किट में होता है. ठीक, अब अगर आप फिर से XC का फॉर्मूला देखें, this is 1 upon 2 pi fc because it was 1 upon omega c. So we may check that two main points are there. First, Xc is inversely proportional to the frequency. That is why if f equal to 0, if f equal to 0, xc equal to infinite. ठीक है, तो f equal to 0 कौन से करंट के लिए होता है? डीसी करंट के लिए. तो जब भी आप सर्किट में से डीसी करंट को फ्लो करेंगे, कैपेसिटर विल ऑफर इनफाइनाइट कैपेसिटिव रिएक्टेंस, दैट इज रेजिस्टेंस. Hence, the circuit will behave as an open circuit, and whenever we will pass AC of high frequency. अब बेटा इसको आप साथ साथ में कंपेयर करते जाओ इंडक्टिव सर्किट से. ठीक है, इंडक्टिव सर्किट में अगर आपने हाई फ्रीक्वेंसी लिया था तो इंडक्टिव रिएक्टेंस बहुत हाई हो गया था, तो कंपोनेंट्स ब्लॉक हो चुके थे. बट कैपेसिटिव रिएक्टेंस में अगर आप हाई फ्रीक्वेंसी कंसीडर करते हैं, so it is good because the capacitive reactance will be low, because the capacitive reactance is inversely proportional to the frequency. Hence, if high frequency AC source is there, then Xc will be low. So it is good for the alternating current. Hence, we can say that a capacitor is suitable for passing AC of high frequencies. So, its behavior is same as that of resistance. Hence, SI unit of capacitive reactance is also as ohm, as it was for the resistance as well as for the inductive reactance. Okay, so this completes the topic for capacitive reactance. So let's do a numerical based on this. Check a question which is based on the AC source connected to a capacitor. Read the question. A capacitor of 2 microfarad, means this is the value of C, is connected to an AC source of EMF E equal to 250 sine 100 pi t. So we can compare it with E equal to E0 sine omega t. Hence by comparison we get that the value of maximum EMF is 250 volt, and the value of omega is, because it is sine omega t, so the value of omega is equal to 100 pi. Write an equation for the instantaneous current through the circuit. So first unknown is the value of I, that is instantaneous current, and the second question is give reading of AC emitter connected in the circuit. the AC emitter read करेगा, emitter है, so it will read the current, but because it is AC emitter, हम लोगों ने पढ़ा हुआ है hot wire emitter यूज करते हैं, because AC की वैल्यू एक फुल साइकिल में 0 होती है, so it will be reading RMS current or the virtual current or the effective current, which is equal to I0 by root 2 or 0.707 multiplied by I0. ठीक है, तो सेकेंड वैल्यू आपको फाइंड करनी है RMS current. So first we are going to find out the instantaneous current, that is the equation for current. सो कैपेसिटिव सर्किट में हम लोग अभी जस्ट डिराइव कर चुके हैं द वैल्यू और इक्वेशन फॉर करंट इज I इज इक्वल टू I0 साइन ओमेगा टी प्लस पाई बाय टू, बिकॉज करंट ईएमएफ से पाई बाय टू एंगल से लीड करती है, आपने यहाँ प्लस लिया था, सो जस्ट टेक द वैल्यूज गिवन इन द क्वेश्चन. C इक्वल टू माइक्रो में है तो आप 2 इंटू 10⁻⁻6 फैराड लेंगे. देन E0 इज 250 volts. Omega is equal to 100 pi and the unit is radian per second, SI unit. Now we may get I equal to I0 का फॉर्मूला होगा आपके पास E0 इंटू ओमेगा C. थियोरी पार्ट को स्ट्रेस करेंगे, ठीक है. साइन ओमेगा टी प्लस पाई बाय 2. So now put all the values. We get I equal to the value of E0 is 250. The value of omega is 100 pi. The value of C is 2 into 10 to the power minus 6 multiplied by sine. Again the value of omega t is 100 pi t plus pi by 2. तो ये टाइम वेरिंग इक्वेशन बन चुका है साइनोसॉइडल. सो वी गेट I इक्वल्स टू ये दोनों को कंबाइन कर देंगे 25 इंटू 2 एंड देन 100 इंटू 10 को 10 के पावर के साथ बैलेंस कर देंगे. सो आफ्टर सॉल्विंग इट कंप्लीटली वी गेट द आंसर एज 25 2 is 50 multiplied by 3.14 multiplied by, check this is 10 raised to 3 into 10 raised to minus 6. So this will be 10 raised to minus 3 into sine 100 pi t plus pi by 2. So we get this answer as 157.1 into 10 raised to minus 3 sine 100 pi t plus pi by 2. The SI unit of the current will be ampere. So we get the final equation for current as 0.157 into sine 100 pi t plus pi by 2. So this is the equation of the current, instantaneous current. Now second thing, we have to find how much current the AC emitter reads. So as AC emitter always reads the RMS current, so we can find the RMS current as I0 divided by root 2. So this is I0. ठीक है, this is I0. So we can write it as 0.157 multiplied by 0.707. So it will reduce the current and we get RMS current as 0.111 ampere. This was a question from State Board. Next we are going to solve a question from NCERT. Check. This is a question from NCERT. On the screen you can check that a 15 microfarad capacitor is connected to a 220 volts 50 hertz source. तो आपको क्वेश्चन में जो भी डायरेक्ट वैल्यू गिवन होती है उसको आप RMS वैल्यू लेते हैं इफ अनलेस स्पेसिफाइड। बट अगर बोला हुआ है पीक वैल्यू तो आप उसको E0 ले लेंगे। बट यहाँ पर आपको कुछ भी स्टेटेड नहीं है, नथिंग इज मेंशन्ड, सो यू विल बी टेकिंग इट एज ERMS and this is the value of C. 50 hertz means this is the value of the frequency of AC source कि एक सेकेंड में complete 50 cycles occur होते हैं। Find the capacitive reactance means first unknown to find is XC and the current. Current के आपको दोनों values निकालने RMS as well as peak. So we can take, we have to find IRMS as well as the maximum value of the current. Now if the frequency is doubled means third जो unknown है आपके पास कि अगर आप frequency को 2F बनाते हैं, what happens to the capacitive reactance and the current? So XC पर क्या effect होगा as well as current पर क्या effect होगा, that we have to show. So let's write first the given data. C equals to 15 multiplied by 10 to the power minus 6 farad. Then E RMS is 220 volt. Frequency is 50 hertz. These are the given data in the question which are mandatory to write for any board exam. Competitives में आप इस तरह से सर्कलिंग मेथड से गिवन डेटा को असेंबल कर लेते हैं. So first is capacitive reactance which is equal to 1 upon omega c or 1 upon 2 pi fc. So let's put all the values. So we get capacitive reactance as 1 upon 2 pi, f के place पर 50 और c के place पर 15 into 10 to the power minus 6. Again assemble the simplest part, that is 50 to 100. 100 को आप इसके साथ कंबाइन कर देंगे, सो दिस विल बी इक्वल टू 1 अपॉन 15 pi multiplied by 10 to the power minus 4. ठीक है, because this is 100 into 10 to the power minus 6. So this is 10 to the power minus 4. Obviously the unit will be ohm. So after solving this we get the answer for XC as 212 ohm. Now the second thing, second unknown check करेंगे. What we have to find out? I RMS and then I 0. तो second unknown के लिए I RMS equal to E RMS upon XC. Ohm's law के जैसे ही फॉर्मूला लिख लेंगे आप. E RMS is 220, XC की value 212. So after solving this, we get the answer for RMS current as 1.04 ampere. Because आपको ये देखकर पता चल रहा है numerator is greater than denominator, and answer will be starting by 1 point. 1 से बड़ा होगा आंसर. Third, peak current will be IRMS multiplied by root 2. So this is 1.04 multiplied by 1.414. This is equal to 1.47 ampere. ठीक है, तो आपको यहाँ से देखो देखकर बिल्कुल क्लियरली पता चल रहा है पॉजिटिव साइड में करंट विल बी गोइंग टिल प्लस 1.47 एम्पियर एंड नेगेटिव हाफ साइकिल में करंट विल बी गोइंग फ्रॉम 0 to minus 1.47 ampere, and because this is a capacitive circuit, so I will lead by pi by 2 radian as compared to the instantaneous EMF. ठीक है, अब एक जो क्वालिटेटिव क्वेश्चन है इसमें कि if the frequency is doubled then what will be the effect on the capacitive reactance and on the current. तो चेक करेंगे कैपेसिटिव रिएक्टेंस का फॉर्मूला होता है आपके पास 1 अपॉन ओमेगा सी. सो दिस इज 1 अपॉन 2 पाई एफ सी. तो अगर आपने फ्रीक्वेंसी को डबल कर दिया बिकॉज XC इज इनवर्सली प्रोपोर्शनल टू F। तो अगर आपने फ्रीक्वेंसी को डबल कर दिया सो XC विल बी हाफ। ठीक है, कैपेसिटिव रिएक्टेंस हाफ हो जाएगा। नेक्स्ट फॉर्मूला लिया आपने I इज इनवर्सली प्रोपोर्शनल टू XC। तो अगर XC हाफ हो जाता है सो I will be doubled। So these are the factors like frequency को जैसे ही आप चेंज करेंगे the value of XC or the current simultaneously go to change। तो इस पर बेस्ड और प्रॉब्लम्स की प्रैक्टिस कर लेंगे इन केस ऑफ एनी